Definition: NMR is a phenomena exhibited by atoms when atomic nuclei in a static magnetic field. This word is very important: static magnetic field. Okay, so external field is applied. These nuclei absorb energy from radio frequency field of certain characteristic frequency. So basically, they absorb the energy from radio waves. It results to give a spectrum with frequency on x-axis and intensity of absorption on y-axis. So, principle and theory of C13 NMR. The nuclear magnetic resonance occurs when nuclei aligned with the applied field are induced to absorb energy and change their orientation with respect to the applied field. In simple word, when they flip. Okay, NMR occurs when nuclei flip by absorbing the energy. Next point, the energy absorption is a quantized process, and energy absorbed must be equal the energy difference between two states, that is the ground state which and the high energy state. Okay, so energy is absorbed is energy of minus half here. Minus half is indication of the spin and plus of is the indication of the other spin. So E minus half and E plus half दोनों में जो difference है, that is the energy absorbed. So it is the energy is equal to the energy of electromagnetic radiation H nu. The stronger the applied magnetic field, greater the energy difference between the two possible spin states. I will repeat this statement. The stronger the applied magnetic field, greater the energy difference between the possible spin states. So the energy is directly proportional to the applied magnetic field. So tell me in the chat box. I am going to state you a statement. You will tell me it is right or wrong. Okay. If I change the magnetic field which is already applied to a higher magnetic strength. Okay. Suppose originally it was say 60,000 units. I change it to 60,100 units. So the nuclei which was resonating previously say on say 100 megahertz. Now because the applied magnetic field has increased, maybe it will resonate at 101 megahertz. तो magnetic field का अगर value change होता है, बढ़ता है, applied energy जो electromagnetic radiation का है वो भी बढ़ना चाहिए. Do you think my statement is right? What do you think? Is the third point is clear to you? Yes, true. Okay, very good. So you people understand it. Very good. The magnitude of energy level separation also depends on the particular nucleus involved. Or nucleus involved, we need to consider the nature of the nucleus. So each nucleus has a different ratio of magnetic moment to angular moment, since each has a different charge and mass. See, the size of the nucleus varies depending on the number of protons and neutrons in it. So the mass of every nucleus is different. Okay, but if you consider the charge to mass ratio, it will be also very specific for the specific. You must have heard charge to mass ratio, mass to charge ratio in case of mass spectrometry. So it is something like that only. Okay, because every nucleus will have different mass. When I say every nucleus, I mean to say element. Okay, this ratio is called as magnetogyric ratio gamma. We have seen definition of magnetogyric ratio. So that gamma is a constant for each nucleus and determines the energy dependence on the magnetic field. So that the ratio depends on the external magnetic field. Okay, so delta E is equal to integration of all the forces of gamma B0 is equal to H nu. So the gamma value of C13 is found out to be 67.28 Tesla, and for H1 it is 267.53. So it is even less than 1/3 of H1. Okay, so that magnetogyric ratio is very small for C13. Okay, now let's talk about abundance of C13. In that video, that fellow said that C13 is very rare. How rare it is? Out of 100 atoms of carbon, only one atom is of C13. Rest 99 atoms, they are C12 types. Now, why it is that we are only considering C13? See, only C13 has odd mass number. That's why only C13 is having a spin quantum number which will give you the magnetic field and which will give you magnetic moment to the nucleus. C12 nucleus will not have any magnetic moment. So whether you are keeping it in external magnetic field or not, it will not perform precisional motion. Now, think and answer. C12 nucleus, I repeat, C12 nucleus, it has a spin, but it cannot perform precisional motion. Do you think it is true or false? Okay, let me give comparative statement because only Shakil could answer. C13 nucleus has spin and it can also perform precisional motion when kept in external magnetic field. C12 nucleus has a spin but cannot perform precisional motion when kept in external magnetic field. Are these statements clear to you? Do you think they are true? Do you have any doubt regarding it? Please do ask. Okay, very good. Now students are getting it. Very good, very good. So, magnetic C13 is much weaker. The reason being the nucleus is relatively larger as compared to H1. Moreover, gyromagnetic ratio of C13 being only 1/4 of that of proton, so the resonance frequency of C13 is also 1/4 of that of proton NMR. I think there is no expression at this point. Now, what are advantages of C13 over H1 NMR? If people are saying that signals are weak, there is very less abundance of C13 over H1. Even the nucleus of C13 will precess and it will get excited at very low energy. There are so many points and concerns. So, do you think it has got any advantage over H1 NMR? See, in H1 NMR, we had to predict the structure, the backbone. See, we all are studying carbon chemistry. So, all the structures that we draw, we first draw carbons. Even when we draw on paper, we first draw carbons. Then we add hydrogens, oxygen, nitrogen to it. So, what is most important part in organic chemistry? It is the backbone of carbon of the structure. So, asking to enter. Okay, I will read out the first point. C13 provides about the backbone of the molecules rather than the periphery. H1 gives you information about the periphery of the molecule. C13 gives the information about the backbone of the molecule. So this is the first advantage. The chemical shift range for C13 NMR for most organic compound is 200 ppm compared to 10 to 15 ppm for H, that is H1 NMR. Hence, there is very less overlap of peaks for C13 NMR. See, for H1 NMR, the scale was 0 to 10, okay, or 0 to 15. 0 being the signal for TMS, and maximum signal would reach to 10 or 15, okay. That was the scale for H1 NMR. So, there was possibility that two signals will overlap. But for C13 NMR, the scale is from 0 to 200. It is a larger scale. So there will be overlap, but the overlap chances and overlap incidences are very rare. So when I say overlap is rare, what factor of the graph has increased? Anybody? Can you guess the word? If there is no overlap, what is better? You can consider this with your HPLC signals. Yes, Pratiksha, brilliant. Pratiksha, you have better resolution. Very good, excellent. Spin-spin coupling between carbon atom is not observed because the natural abundance of C13 is too low for two C13 to be next to one another. See, देखो spin-spin coupling H1 NMR में क्यों होता था? क्योंकि दो न्यूक्लियस H1 के वो एक दूसरे के जब करीब आते थे के सिग्नल को डिस्टर्ब करते थे। लेकिन C13 के केस में इट इज वेरी रेयर दैट यू विल गेट टू C13 adjacent to each other, almost near to impossible. So if there is no C13 nucleus adjacent to the C13, it is impossible for it to give coupling. So there is no spin splitting. अच्छा, अगर spin splitting नहीं होता है, इसका मतलब क्या है? इसका मतलब क्या है? You will get one signal for one carbon. Isn't it brilliant? So one carbon, one signal. So suppose in my molecule I have 10 carbons. How many signals should I expect? This is googly question. In a molecule, suppose there are 10 carbons. So should I expect 10 signals? At least tell yes or no. Okay, people are saying one signal. Some people are saying no. Okay, if you are guessing that no, I cannot expect 10 signals for 10 carbons, so you are logically right. The reason being, we don't know in what environment that carbons are present. Suppose there are 6 carbons and all of them are present in the same environment, then all of them will give you the exactly same signal. Okay, now in this case the intensity of that single signal will be 10 times, 6 times I should say. There are 6 carbons, so intensity will be 6 times. Are you trying to correlate this logic with H1 NMR? दोनों में similarity दिख रहा है क्या? देखो क्या होता है, I will try to simplify it. अगर 2 कार्बन हैं और दोनों अलग अलग एनवायरनमेंट में हैं, तो मुझे 2 सिग्नल मिलेंगे, दोनों का समझो 1 यूनिट होगा. एब्जॉर्प्शन इंटेंसिटी इज 1 यूनिट. अभी ऐसे इमेजिन करो दोनों का एनवायरनमेंट सेम है. इफ द एनवायरनमेंट ऑफ बोथ द कार्बन्स आर सेम, they will give me one signal, but because there are 2 carbons present, the intensity of the signal will be double. It will be 2 units. Do you follow it now? Yes. Thank you, Kajal, Shakil, Jali, Archana. Thank you, Priyanka. Okay, I will continue with the same point. Heteronuclear spin coupling between C13 and C12 does not occur because spin quantum number of C12 is 0. So this is but obvious. We already covered that when we discussed about coupling between 2 C13s. There are a number of excellent methods for decoupling the interaction between C and H1. Now this 4th point is very much interesting. See, imagine apply to a carbon containing molecule. Try to imagine in your head that C13 nuclei are arranging themselves in the direction of the external magnetic field while they are precessing, while they are performing precisional motion. Along with them, H1 nuclei, proton nuclei, will also start performing precisional motion. I hope you can see in your head. I hope you can imagine. Now, although C13 is not adjacent to C13, C13 is definitely 100% adjacent to H1 NMR. H1 nuclei. That H1 nuclei is itself a magnet in motion, which is precessing. So that precessing H1 nuclei may influence the spin of precessing C13 nuclei. I hope you can imagine in your head. See, when we say that C13 gets excited easily because its gyromagnetic ratio is weak, but it doesn't matter how much weak the external magnetic field is, it will make all the nuclei which has got spin quantum number as odd to align themselves in the direction of magnetic field. So we are also going to study certain methods of decoupling. Okay, we are going to study decoupling का मतलब, coupling का मतलब क्या होता है? 2 न्यूक्लियाई में कपलिंग हो रहा है, इसका मतलब क्या होता है? एक दूसरे के सिग्नल को, एक दूसरे के फ्रीक्वेंसी को वो अफेक्ट कर रहे हैं. तो डीकपलिंग का मतलब क्या होगा? उसका अपोजिट. एक न्यूक्लियस का जो इफेक्ट है दूसरे न्यूक्लियस पे, उसको हम न्यूट्रलाइज कर रहे हैं, उसको कहते हैं डीकपलिंग. ओके, लेट्स मूव फॉरवर्ड. We have seen chemical shifts in H1 NMR. Now let us take a brief idea about chemical shifts in C13 NMR. Most significant factors affecting the chemical shifts are electronegativity of the group attached directly to the carbon, hybridization of the carbon itself, and the intensity or the size of each peak is not directly related to the number of that type of carbon. Now, this particular point is not in contradiction with what we have seen अभी के जैसे दो कार्बन है सेम एनवायरनमेंट में तो डबल इंटेंसिटी होगा. See, what happens is the rarity of the C13 is the reason that why this is not observed sometimes. कि एक एनवायरनमेंट में अगर दो कार्बन है तो ऐसा नेसेसरी नहीं है कि वो उसका पीक हाइट डबल होना चाहिए. Theoretically that is right, but practically it is not observed. Why it is not observed? Because of the rarity of C13 atoms. Okay, there are other factors also that can contribute. Now, do you need explanation on electronegativity and hybridization? इसका explanation मैंने दे दिया third का. Do you require it or you will guess it? Can somebody tell me how electronegativity will affect? Anybody can unmute and tell me. Simple है, imagine करो अभी कार्बन को दो एटम्स कनेक्टेड है. एक केस में कार्बन को नाइट्रोजन कनेक्टेड है और दूसरे केस में कार्बन को क्लोरीन कनेक्टेड है. दोनों में से ज्यादा इलेक्ट्रोनेगेटिव कौन है? क्लोरीन. तो दोनों कार्बन में से कार्बन नाइट्रोजन वाले कंपाउंड का ज्यादा डीशील्डिंग होगा या कार्बन क्लोरीन वाले का ज्यादा डीशील्डिंग होगा? किसका ज्यादा डीशील्डिंग हो सकता है? द कार्बन वन. वेरी गुड प्रियंका, सृष्टि, माधव, वेरी गुड निकिता, very good people. Now, same with hybridization. When we talk about hybridization, we need to consider the percentage of S character. Okay, so if the percentage of S character is more, I think you know what is percentage of S character. Okay, see, there is sp hybridization, sp2 hybridization, and sp3 hybridization. In which type of hybridization the percentage of S character is more? It is सबसे ज्यादा किसमें है और वो कितना है? Oh, you people forgot actually. It was important part of your syllabus. Percentage of S character. Yes, Priyanka, right. sp देखो sp में कितने ऑर्बिटल है which are undergoing hybridization, and out of those two, one is S. So 50% S character हो गया. sp2 में कितने हाइब्रिडाइजेशन हो रहे हैं? कितने ऑर्बिटल के? तीन के. तीन में से एक क्या है? S है. तो इसका परसेंटेज क्या हो गया? Anybody? It will be 33%. 1 divided by 3. And what about sp3? It will be 1 divided by 4. तो परसेंटेज कितना होगा? It will be 25%. अच्छा, अगर किसी को अगर ये नहीं याद आ रहा है तो एक बार go back to your basics and calculate it. So जितना ज्यादा S कैरेक्टर होगा वो जो कार्बन है उसका शील्डिंग उतना ज्यादा होगा. Because S electrons they are performing the motion more near to the nucleus, so they are shielding the nucleus. See, other factors are also there to contribute. Peaks from carbon atoms that have attached hydrogen atoms are bigger than those that don't have hydrogen attached. So this is one observation. Carbon chemical shifts are usually reported as downfield from the carbon signal of tetramethylsilane. So ये तो it is bound to happen. It has to be downfield. Now these are the ranges of. I should increase the. Okay, now you will be able to see. This is primary carbon. This is secondary carbon. This is tertiary and quaternary carbon. All of them are sp3 hybridized. You can see that these are shielded. Okay, the specifies no electronegative element is attached to the carbon directly. This is the condition. Then you have sp3 hybridized where there is electronegative element attached. You can see the moment electronegative element is attached, all of them have shifted downfield. Then you have sp3 and sp2 hybridized carbons, carbonyl groups. Okay, we mentioned that there is something called as proton decoupling. जो कार्बन के साथ प्रोटॉन का कपलिंग होता है उसको डीकपलिंग करना पड़ेगा. तो उसके तीन टाइप्स है. वन, ब्रॉड बैंड डीकपलिंग. सेकंड, ऑफ रेजोनेंस डीकपलिंग. थर्ड, पल्स डीकपलिंग. स्टार्ट विथ बैंड डीकपलिंग. The word broadband itself gives fair bit of idea. Okay, what is done is the molecule is kept in external magnetic field. All right, the molecule is kept in external magnetic field. Now, obviously, the both C13 and H1 will align themselves either in the direction or against the direction of the magnetic field. Now, problem happens when H1 has coupling interaction with C13. So, what they do is they bombard the molecule with very broad band of electromagnetic radiation of radio frequency, and because of this broad band, continuous supply of the energy is given to the molecule. Okay, and the radio frequency is adjusted such all H1 will get resonated and they will flip. Okay, they will flip to go to the higher energy level. Okay, so such a high energy is provided. So when this is happening, because the absorption is quantized, this range of spectrum is not suitable for C13. It is not suitable for C13. So they will remain at ground state. Okay, I hope you can imagine this. So if the flipping of H1 is already occurred and they are gone to higher energy state, they will not couple with C13.